Hi guys, in this video we are going to discuss 28th January evening session paper, and this was considered as the second most toughest paper of all mathematics papers in January session. Let's see whether it is really tough or not, right? So we'll start with the first question itself. So the first question is given statement question. Yeah. So nowadays in this session statement questions are also asked. Now see the first statement. What is given? 25 power 13, 20 power 13, 8 power 13, 3 power 13 is divisible by 7, right? So the summation is divisible by 7. So in mathematics we have this: if n is odd, if n belongs to odd, then we can write x power n plus y power n equals to x plus y into x power n minus 1 minus x power n minus 2 into y plus x power n minus 3 into y square minus and so on, right? We can write like this. So which indicates clearly that if n is odd, x power n plus y power n is divisible by x plus y. Can I say that? Right? So using this statement we can solve this question. Now here clearly you can see the summation. So what we can do is here, yeah, so 25 power 13, and I will club with 3 power 13 because I can get 25 plus 3 28. So 25 power 13 and 3 power 13, as n is odd here, it is divisible by 25 plus 3, that means 28. So it is of the form 28k, where k is an integer, right? Similarly here it is also 20 power 13 plus 8 power 13 is also, let us say this is k1, right? So you can write this one as 28k2 because it is also divisible by x plus y, which is nothing but 28. Some k2 belongs to integers. So overallly it is of the form 28k form, right, which is divisible by 7. So the statement 1 is true, right? Next, statement 2. So the integral part of this one is an odd number, right? So now statement 2, what is given here? 7 plus 4 root 3 whole power 12. Now you need, sorry, whole power 25, right? So whole power 25. Now you need to show that the integral part of this is an odd integer, right? So what I will do is I will consider this one as some integral part as I and the fractional part as small f, right? So here I plus f is 7 plus 4 root 3 whole power 25. Now if I expand it, I will get 25 c naught using binomial expansion. I can expand it, 25 plus 7, 25 c1, 7 power 24, 4 root 3, right, plus 25 c2, 7 power 24, 23, 4 root 3 whole square, plus and so on, 25 c25, 4 root 3 whole power 25, right? So this is the expansion. Let consider capital F as 7 minus 4 root 3 whole power 25. I am taking the conjugate of this particular expression, right? So now what I can do is here, if I expand this one, I will get 25 c naught 7 power 25 minus 25 c1 7 power 24 into 4 root 3 plus 25 c2 7 power 23 into 4 root 3 whole square. So let me write here clearly, plus 25 c2 7 power 23 into 4 root 3 whole square minus and so on, right? Now I have this I plus 5 f expansion and f expansion. What I will do is I will add them up, I plus f, or sorry, I plus small f plus capital F, okay, is, so if I add them up, the irrational terms will be cancelled out because we are left out with 4 root 3 whole square. If you square it of 4 root 3 whole square, or if you apply even power, it will become proper integer, right? So what I will get, 2 times of 25 c naught 7 power 25 plus 25 c2 7 power 23 times 4 root 3 whole square plus 25 c4 7 power 21 4 root 3 power 4 plus and so on, right? If you see the inside terms, this way, this is an integer, this is an integer, this is also an integer, because 4 root 3 have power 2 and here 4 root 3 have power 4, so that will become integer. Can I say it is of the form 2k, right? Now I plus f plus capital F is 2k. Now we have considered this one as an integral part, right, of that one integral part, and this one as fractional part, right? So we already know fractional part of any number is between 0 to 1. So can I say small f is between 0 to 1, right? Now coming to capital F is 7 minus 4 root 3 whole power 25. Here 4 root 3 means you can write it as 1.5 something around into 4, right? So you'll have 6 point something. 6 point something means in the inside value is less than 1, or that means 0 point something like that. If you are applying higher power, this is always less than 1. So what I meant to tell you is capital F is between 0 to 1, right? And it is always positive because the inside value is positive and it is having an exponent, right? So small capital F is 0 to 1, small f is between 0 to 1. Now if I sum them up, so what I will be getting, 0 less than capital F plus small f less than 2, right? Now here you can see here I from this equation I is an integer and plus f you are getting an integer, even integer. Now if this should happen, then if I is an integer, small f plus capital F should also be an integer, right? And small f plus capital F is between 0 to 2. Now the integer between 0 to 2 is definitely 1. So what I can say is f plus f value is 1. So I can write I plus 1 equals to 2k. Now I is equals to 2k minus 1. So which is nothing but odd format of the number. So can I say the integral part of this particular expression or expansion is an odd number, right? So the statement 2 is integral part is an odd number. Statement 2 is also right. So both statement 1 and 2 are true. So second option is right. So next let's move to second question. So what is given here? Second question, the sum of the coefficients of x power 499, x power 500 in this particular expansion, right? So let's try it. So clearly the given expansion, if you observe the given expansion here or expression here, can I say it is in GP? How can we say it is in GP? If you take the ratio, so what I can see is x into 1 plus x whole power 999 by 1 plus x whole power 1000. So what you are getting, x by 1 plus x, right? Because this will cancel out. And similarly, if you take the ratio of these two also, you get the x by 1 plus x. So this is clearly a GP. Whatever expansion is given, that is a GP. Now let's sort it out, find the sum of the GP. So SC equals to, we already know the formula, A into, A means first term. So I'm writing this formula here, A into R power n minus 1 by R minus 1, right? Where R is the common ratio and A is the first term. You can write here like this, 1 plus x whole power 1000. So common ratio is x by 1 plus x whole power. How many terms are there? Here 1 plus x whole power 1002. Here 1 plus x whole power 0 we can assume, right? So that means 1001 terms are there. 1001 minus 1 by x by 1 plus x minus 1, right? Let's sort it out. So 1 plus x whole power 1000 to x power 1001 minus 1 plus x whole power 1001 by x minus 1, this one you will get minus 1 by 1 plus x, and here I am getting 1 plus x whole power 1001 is also there. So this one will cancel and you will get 1000, and this one will be cancelled out. So minus is there, so we will be getting with x plus 1 whole power, or I can write 1 plus x whole power 1001 minus x power 1001. So this is the summation we got, right? Now the question is asking coefficient of x power 499, x power 500. So coefficient of x power 499 is 1001 C 499, right? Similarly, coefficient of x power 500 is 1001 C 500, right? Now they are asking for sum of the coefficients, right? So you need to sum them up. So 1001 C 499 plus 1001 C 500. So it is of the form NCR minus 1 plus NCR. Now what's the formula? N plus 1 CR. So we can write 1002 C 500. So this is the answer, 1002 C 500. So where it is? Second option.